Okay, let's start with my favorite, the sympathetic nervous system. Let's go cuckoo. Okay, so in the sympathetic nervous system, let's describe the structures that we said before we're going to describe. So, in this sympathetic division of the autonomic nervous system, the preganglionic neurons are located on the lateral gray horn in the spinal cord segments from T1 to L2. So preganglionic neurons are located on lateral gray horn, horn from T1 to L2. Okay, those are, in here's where we're going to find the bodies of those neurons, or the soma. Now, the axons, the preganglionic fibers. The preganglionic fibers, remember, they are thinly myelinated, and they're going to reach the ganglionic neuron. Now, these ganglionic neurons are located very close to the spinal cord. They have three different locations. They form let me put here, they form the sympathetic chain ganglia. This is an N. They form, or they are located also in collateral ganglia. And the third location is the adrenal medulla. Okay, so let me show you in this picture. This is your spinal cord. This is the dorsal root ganglia part, the sensory ganglia of the somatic nervous system. Now, look how everything gets complicated little by little. These are the sympathetic chain ganglia. It's a chain, literally, like a bead of a necklace on either side of the vertebral column. Okay, and all of those are the ganglias, and we have them from your neck to down there to your lumbar segments. Those are the sympathetic chain ganglia, one location. The other location of these ganglionic neurons, look how they look like, okay? This is, in here we can see, the behind that, posterior to that, we have the spinal cord. So look how close to the spinal cord the ganglia are. So these are the sympathetic chain ganglia, one of the locations, see, all of that. We have the second location, remember, is on the collateral ganglia. And the collateral ganglia are especially three, like about here and about here. There are three ganglia, we call it celiac, superior, inferior, mesenteric ganglia. The thing is, our ganglia is located within the abdominal cavity. And as you can see, again, they're very close. They're right in front of the vertebral column, right there. And the third location are here. This is the adrenal medulla. And the adrenal medulla is this, it looks like a little piece of fat. It's not fat. It's a gland on top of the kidneys. Now, the kidneys are renal. So suprarenal gland are these glands above or on top of the kidneys, and they're cool because these are complicated structures. They're part of the endocrine system. It's a gland, it's an endocrine gland, produces hormones, but these hormones, or this is also part of the nervous system, the autonomic nervous system. So ganglionic fibers, this is like a modified ganglia. And ganglionic fibers in here are going to produce the hormones or the neurotransmitters, which is adrenaline and noradrenaline, or maybe you know them as epinephrine and norepinephrine. It's the same. Okay? So those are the location of the ganglionic neurons. Now, from those in here, in this image, we have, well, the preganglionic neuron, remember, in the central nervous system, specifically in the lateral gray horn of the spinal cord segments from T1 to L2. The ganglionic neurons are located on the ganglia, and these ganglia are in 3 different locations. 1, sympathetic chain ganglia. 2, collateral ganglia in the abdominal cavity. And 3, the adrenal medulla on top of the kidneys. So, in these 3 locations, the ganglia are very close to the spinal cord, right there, okay? What is important about knowing they're right there is, let me put it in red maybe, that the preganglionic fibers, okay, which are, remember, the axons of these neurons, the axons of the preganglionic neurons, are very short, okay? And they're short because, well, short. We're right there, okay? Right there from the spinal cord to in front of the vertebral column or to the sides of the vertebral column. We're right there. So these preganglionic fibers are very short, but the postganglionic fibers are very long. Why? Because from that location, very close to the vertebral column, these postganglionic fibers, which are the axons of the ganglionic neurons, they have to travel all the way to reach the different target organs. So they have to go to the heart, to the lungs, to the eye, to the skin. Sympathetic nervous system innervates the skin, the muscles, or I don't see them in here, the skeletal muscles, well, not the skeletal muscle, the blood vessels that supplies the skeletal muscles, because the skeletal muscles are part of the somatic nervous system. So let's see what are the effects of the sympathetic stimulation on these organs, okay? But before that, we have another picture. Well, in this one, I show you this one at the beginning of the class, is just to review these same structures in this image. So again, preganglionic neurons are located on the lateral gray horn of the spinal cord, segments from T1 to L2. Look at the thinly myelinated axons of these neurons are the short preganglionic fibers that reach a ganglia. This peripheral ganglia, which is a motor ganglia, contains the ganglionic neurons, the cell body of the ganglionic neurons. Where can we find these ganglia? Very close to the spinal cord, either in the sympathetic chain ganglia, in the collateral ganglia, or in the adrenal medulla. From there, so we're going to have long unmyelinated axons, which are the postganglionic fibers reaching the target organ. Now, in the first synapse between the preganglionic and the ganglionic neuron, in here, the neurotransmitter released is acetylcholine, just like we have described in the other synapses. But the neurotransmitter released by the sympathetic postganglionic fibers, and maybe we can add this in here, is noradrenaline or norepinephrine. Okay, let's put it in blue. Okay, these short preganglionic fibers, they release acetylcholine. My goodness, that's an A. And the long postganglionic fibers, they release norepinephrine, which is the same as saying noradrenaline. Okay? And they're going to stimulate, in this example, in the heart, they're going to stimulate the heart to contract faster and stronger, not only faster, but with more force of contraction. Now, let's see the effects now. Okay, so let's describe the situation first. In the sympathetic nervous system, it makes your body ready to fly or fight. Okay, so it makes your body ready to fight, to challenge the other one, or to run away. Okay, so let's imagine that you are camping and you get, in the morning, you get out of your tent and you see that bear. The first thing, and I think I'm feeling it right now, the first thing, you're gonna feel your heart pounding, okay? You're gonna feel your heart rate increasing. You're going to, and why is the heart rate increasing? Just to deliver more blood to your organs, okay? To make you ready to fight or flight. You increase your respiratory rate. Why? Because you're inhaling more oxygen, so you oxygenate more, you deliver more oxygen to your brain, and to all of the organs are going to respond in this emergency situation. What else you're going to feel? You're going to feel in your skin, it's not in here, but in your skin, you're going to feel maybe sweaty, and maybe you're going to have goosebumps. The muscles in your skin, they contract, and you're going to have goosebumps. So you're sweaty, you are shaking, your heart rate is increased, your respiratory rate is increased, your brain is acting like crazy. It increases the level of alertness to a level that you, after that situation, the emergency situation passes, you say, wow, how did I do that, right? Sympathetic nervous system in action. So increases your level of alertness in the brain. Your eyes, the pupil of the eyes, it just dilates, which means that increases on the diameter, it just gets bigger, so you can perceive more clearly all the you have an increased visual field in there. What else? The blood vessels are vasodilated, and it means that they are opened up in order to deliver more blood, especially to your skeletal muscles. You're ready to run, or to ready to run or punch. Your liver is releasing glucose like crazy just to feed your brain and your skeletal muscles in that emergency situation. Now, the last thing that you need in there is that, imagine that you're square like that, ready to fight the bear, or to growl back at him, or you're ready to fly, and you're gonna say, oh, excuse me, I need to pee, I need to poo. At that moment, that's the last thing you need. So in that moment, your digestive system or your digestive functions are, put on hold for you. The same thing in the urinary system. Making pee-pee is not an option now. It's not part, we're dealing with more stressful situations than pooing and peeing. So those things are inhibits, those functions are inhibited in that moment. You don't want to look like you're scared. You're not going to be tearing, or you're not going to be crying at that time. You're not going to see tears at that time. Later, maybe. You're not going to be drooling. All of those functions are inhibited. So no tears, no saliva, no peeing, no pooping. Okay, the only thing that you're secreting in there is sweat. Okay, the rest are inhibited in here, or stopped for functioning. Okay, so that makes you ready to fight or flight.